Before you lies a simulation involving how light affects molecules. Here we have our trusty light-emitting source, and on this side we have our molecule. If you look to your right here, there's a table which has all our different kinds of molecules we will be using today. We'll first start with carbon monoxide, which is CO. And this is our meter for the intensity of the light emitting machine. So we will see how these react. Full power. So we observe here how microwaves will mainly go through the molecule and every once in a while hit the molecule and reposition the molecule. Here we have nitrogen. See how microwaves just pass right through it? This substance is translucent to this light. And we'll move to oxygen. And it goes straight through. Carbon dioxide we will look at next. It goes straight through. And water, which is H2O. Most of it is absorbed and re-emitted, and it repositions the water molecule. What is important to realize about this is your common conventional microwave is basically used in this way. Your food contains an amount of water, which is H2O, and your microwave oven bombards this food with microwaves. What the microwaves do is excite the water molecule, and if you increase its vibration, then you increase the overall temperature of that molecule. Thenceforth, increasing the heat of your food. It's noticed that it's a lot easier to heat water than it is to heat a substance with very little water because of this application. Similarly, this molecule is affected the same way. And O3 is affected the same way. And an application of this is the sun creates all forms of light from radio waves to gamma rays. And O3, showing here, will actually absorb some of the light and reflect it outwards, protecting us biological beings from the harmful rays of the sun. We will now switch back to the top and change our light source. Here we have an infrared emitting device. So essentially, we're vibrating the molecules and every once in a while absorbing the light and reflecting it outwards. Nitrogen gas still not reacting to light. Oxygen gas not reacting to it. Carbon monoxide vibrating violently due to this light. Same with the water molecule. And O3. So if you look here, O3 is once again absorbing and reflecting the infrared light, which is part of the electromagnetic spectrum, which comes from the sun. We'll switch back to the top. Visible light. Every once in a while it'll by a different molecule. It just passes through carbon monoxide, passes right through nitrogen, passes right through oxygen, passes right through carbon dioxide, passes right through water, every once in a while getting absorbed and re-emitted by nitrogen dioxide. And not being absorbed by O3. And visible light is not a harmful light, so it's good that this molecule doesn't absorb it. We'll switch now to ultraviolet. Passes right through the molecule, passes right through oxygen, passes right through the O2, passes right through carbon dioxide, passes right through water, and breaks up nitrogen dioxide, breaks up O3. So when O3 is absorbed, this light, it breaks the bond, the weakest bond, and absorbing the light. And in reality, there are quite large amount of ozone, and so there would be hundreds, if not thousands, of these molecules in our atmosphere, and they would be absorbing ultraviolet light, and due to absorbing it, they end up breaking the strong oxygen or the weak oxygen bond, forming one single oxygen and forming dioxygen, which is the oxygen we breathe. O3 is actually quite poisonous to our body. But that is how light influences molecules. Hope you enjoyed my exploration, and there'll be many more. Have a good day.